Hello everyone, I'm İrem Kalafat. I'm a PhD candidate in Kadir Has University, which is based in Istanbul, Turkey. I also work as a data scientist in Doğuş Technology. Today I will be presenting our work that we have conducted with my colleague Ayça Yerlikaya, and I'm going to start with sharing my screen. Okay, so our work is called Improving Customer Experience in Retail with ML-based recommendation systems. And in our talk today, we will be diving into the scalable hybrids and deep learning approaches that we have developed using large-scale retail transaction data. Uh, and this is the focus of our study. We aim to provide a comprehensive comparison of some various recommendation techniques and highlight the advantages of some hybrid models. So this is the roadmap for my presentation. I will begin with an introduction, and of course, it will follow up with the problem statements. I will move on to the methodology part, where I will share the details of the algorithms we have used. After that, we will analyze the results and discussion. And finally, I will wrap up with conclusion and feature work. So now let's dive into the core challenges that we are addressing, working with the large-scale retail data, actually. The first problem was the cold start problem, of course, and this occurs when a new user or a new product enters the system. So without any kind of historical data, it is kind of hard to make a relevant recommendation for that user or for that product. And the second one is data sparsity. And I mean, even with millions of transactions, the number of items a single customer interacts with is a tiny fraction of the total available inventory. So this results in a very sparse data set, and it kind of makes it difficult to find the meaningful patterns. And the final challenge was the scalability, of course, as the number of customers and the products grows. It's kind of harder for algorithms to find the best solution. And also it's kind of harder to make those solution in a timely way. So in order to overcome those kind of challenges, we have evaluated a diverse set of recommendation strategies. We have started with the fundamentals, which were user-based collaborative filtering, which identifies the similar users from the historical interactions. After that, we have moved on to item-based collaborative filtering and content-based filtering for utilizing the product attributes and user preferences. And we have recognized that the limitations of any single method. So we have explored some hybrid approach to combine the both user-based and item-based techniques, greater robustness, actually. And also a key component of our research was the Cascade recommendation model. This is a multi-stage ranking process. It refines the candidate items and allows us to handle large data sets more effectively, actually. And finally, we have developed into the deep learning with RNN-based next basket model. And this approach here uses recurrent architectures to model the sequential patterns in the purchase behavior of a customer. So now let's zoom into our core solution, the three-stage cascade model. And this model here is a pipeline designed to incrementally build and refine the set of recommendations. And firstly, we have start with user-based collaborative filtering to find the top similar users and aggregate their interactions. And after that, we have introduced the item-based collaborative filtering. We have used the pre-computed item similarity matrix, and we find items related to our initial seed, actually. And finally, we have used content-based backfilling. This is where we tackled the call start and tail item problem. We have vectorized product descriptions using TF-IDF methods. And I mean, the power of this design actually relies, it kind of yields a high precision seed, and it improves the relevance through co-purchase structures, cross-selling patterns. So with the help of this kind of methodology, we can provide recommendations for new and less popular items. Now let's turn to our results. We have metrics for precision, recall, and F1 scores, all calculated at a cutoff 10 items. And as we look across the charts, we can say that in terms of actually the F1 score, Cascade model here actually works the best among other algorithms. And it kind of demonstrates that it has a superior practical performance on a large-scale data set. And as a conclusion, our key findings showed that a clear trade-off within different models. So item-based is reliable for recurring purchases, and content-based filtering is great for cold start. But in order to capture the whole temporal dynamics and kind of bringing the best of the algorithms together, we are decided that going with an hybrid model like Cascade models actually is the best for this kind of problem. Thank you for listening. It was great to share our results with you. Goodbye.